Okay, in this lecture we're going to talk about the price elasticity of demand, which is section 5.1. But in fact, in this chapter 5, we talk about this concept of elasticity, not only in terms of price elasticity of demand, but in terms of other elasticities, and we'll be seeing those in the next lectures. So I want to back up before we get into price elasticity of demand and talk about elasticity more generally. So here on the very first page of this chapter, you have this general formula for elasticity. And the left-hand side is just notation. E for elasticity, and then Y comma X. This is subscripted. And what this means is, say we have two variables. Y, maybe quantity demanded, and X, maybe price. So this will tell us how a percentage change in price, what type of percentage change in quantity demand that leads to. So this will make more sense as we go forward. But I have a couple of other things that I want to do before we get into the chapter details. So what is elasticity? Well, in general, it's a measure of responsiveness. And so in particular, how responsive one variable is to another, right? Like we know by the law of demand that when price increases, quantity demanded decreases. But does it decrease by a lot or only a little? If you know the elasticity, then you will be able to say whether it increases by a lot or a little. So for example, for cigarettes, if the price of cigarettes goes up and people are addicted, the quantity demanded is not going to go down very much. But if the price of Pepsi goes up and the price of Coke and everything else stays the same, people will probably consume a lot less Pepsi, right? Because they'll switch to Coke. So that's what price elasticity of demand tells us. But it's actually a very important concept for many policy issues. And so I want to relate it to the discussion we had about minimum wage laws in the lecture 4.2. So there we had demand for labor. And you'll recall that in the labor market, demand for labor comes from who? Households or firms? Firms, right. And then the supply of labor comes from households. And the quantity down here is jobs or hours worked, if you want, and then the price is known as a wage in labor markets. And so at this equilibrium, the wage may be low. Maybe it's only $5 an hour. And so some people will advocate imposing a minimum wage law in the economy. And in fact, this is a very timely debate. This is being discussed right now at the federal level for a national minimum wage. There are also state minimum wages and city minimum wages too. But right now, Congress and the Obama administration are debating a national minimum wage, and I forget exactly what they're thinking about raising it to, but it's around like maybe $11 an hour. Now, for the folks who get to keep their jobs, this is great because their wage goes up from something lower than that to $11 an hour. But notice what happens. Well, we had at the equilibrium before the minimum wage some quantity, say 100, but then after we had this quantity, maybe say 70. So there was a response, right? When the price of labor went up, firms responded. The quantity they demanded fell, right? From 100 to 70. And so it's good for those who get to keep their jobs, but bad for those who lose their jobs. But some proponents of minimum wage laws think demand is not that responsive. In other words, it looks more like this. Then, if this is what demand looks like, we have the equilibrium point here as before, but once the minimum wage goes in effect, quantity demanded falls, but not by as much, right? It falls only maybe to, say, 90. So in other words, if the demand looks like this, then the minimum wage leads to a smaller loss in jobs, right? It's still a downward sloping demand curve, right? It's just steeper. And so this is a graphical depiction of elasticity. Though I do want to caution you one very important thing. The concept of elasticity and the slope of the line are different. They're related, but they're different. In this chapter, we're going to talk about 4 different types of elasticity. All of them use the same general formula. The one we talk about in this video, in this section, 5.1, is price elasticity of demand. But we'll talk about in the subsequent videos price elasticity of supply, and then also income elasticity of demand and cross price elasticity of demand. So this is a general formula. And so for price elasticity of demand, we can denote this, rather than saying, this kind of long expression, we can write just E sub Q comma P. So this is, if you relate it back to up here, Y would be, in this case, QD, and X in this case would be P. So we have, for price elasticity of demand, percentage change. And this is, by the way, this triangle is a Greek delta. And we use it to denote change. So shorthand for change. So percentage change in quantity demanded over percentage change in price. So this is the price elasticity of demand. And this is probably the best notation to use because it corresponds with this. However, the book uses an even shorter notation, which is just ED. And so I'll use that. But I want you to note that this is, technically, what is changing is the quantity demanded, right? We're measuring a percentage change in quantity demand, right? But we're just going to say D, and you should know when you see that it's actually quantity demand. And let me just say one final thing. This is a pretty easy formula. If I tell you that the price increased by 10%, and that caused quantity demanded to fall by 20%, we could calculate the price elasticity of demand, right? So the percentage change in price is 10%, say, and that leads to a 20% change in quantity demanded. So therefore, what's the price elasticity of demand? It's 20 over 10 equals 2. It turns out this would be negative 20, wouldn't it? If this isn't a positive, if the price goes up, quantity demanded would fall. So we should say negative 2. In this example, these percentage changes are given. But we're going to have to calculate those. And that is a further complication. But it doesn't need to be complicated as long as we just can keep track of what is going on. So, okay, so now getting back to this section 5.1, price elasticity of demand. We've already been talking about it. But how do we compute it? Here's this formula in the book. You see the same thing I wrote a moment ago. Let's say we have this demand curve. And we want to know what's the price elasticity of demand between points A and B. So at point A, the price is 80 cents. At point B, the price is 70 cents. So let's say we go from 80 to 70. What percentage change is that? 12.5. Because we have the change is 10 cents. And we started at 80 cents. So that's 0.125. This is a decimal. If we want to turn this into a percent, what do? Multiply by 100 and add a percent sign. So to turn this into a percent, we take 0.125 times 100 and add percent sign. So this is equivalent to 12.5%. But I want you to notice something, because here we went from A to B, 80 to 70. What if instead we went from B to A, 70 to 80? Now that's an increase. What percentage increase is that? The change is the same, right? It's 0.1% increase, but now it's over 0.7. And so this is not 12.5%. And in fact, this is 14.29. 0.1429 or 14.29%. So therefore, even though the way I've just illustrated to calculate a percentage change is the most common one, right? So like if you were making $100,000 a year, and then next year you're making $110,000 a year, that means you got a what percentage increase raise? From 100,000 to 110,000, that's a 10% increase, right, in your wage. That's how most people think about percentage changes, and that's correct. But we want to say, what's the percentage change? We want to calculate elasticity between these points. And we may not know whether we're going from A to B or from B to A, so we adopt a different method. And you can read about the reason for this in this heads up. I encourage you to read this heads up because it does clarify why we are calculating percentage changes in a way you probably haven't seen before. Okay, so we want to calculate the price elasticity of demand between points A and B. So remember, the general formula for price elasticity of demand is percentage change in quantity demanded over percentage change in price. So we need to now calculate percentage change in quantity demand. What's this? So remember, this is the general formula, but now we need to calculate the numerator. So what's the percentage change in quantity demanded? Well, we see at point A, quantity demanded is 40. At point B, it's 60. So the change in Q is 20,000. I'm running out of room, so I'm just going to write 20, and you should know that's 20,000. And then the change, what do we put this over? Well, it turns out we're going to put it over 50. Why? Because 50 is the average of 40 and 60. So Q bar denotes Q average, and that's 50. So what is this? This equals 0.4. And if we want to turn this into a percent, we know that that is 40%. Let's keep that over here for reference later. And now we'll calculate percentage change in price. So here we go from 80 to 70. So the change in price is 10 cents, and then the average price is 75 cents, right? You can find this by taking 0.8 plus 0.7 and divided by 2. You find this is 0.75. But there's actually an easier way to see that. Just look at these 2 points and find the middle point. So normally you don't have to do the math. You can just look at the graph and see. And then this turns out to be 0.1333 or 13.33%. So let's keep that over here. The percentage change in price is 13.33%. So now what do? Go back to our general formula, which is up here, and plug these in. So we have the price elasticity of demand is 40% over 13.33%, and this equals 3. I forgot to mention something important. This would be negative. So this should be negative 3. Let me emphasize that a little more clearly. Negative 3. And why is that? Well, if we go from A to B, we have a decrease in price, right? And that leads to an increase in quantity demanded. So there, the percentage change in price would be negative. If instead we go from B to A, then that's an increase in price, but that's associated with a decrease in quantity demanded. So there, the percentage change in price would be positive, but the percentage change in quantity demanded would be negative. So in other words, we're talking about price elasticity of demand. One of these percentage changes is always going to be negative. That's the law of demand, right? So therefore, this is always going to be negative. And it turns out, so we say the elasticity is negative 3. Or sometimes we talk about an absolute value, we just say 3. We know it's always negative. Sometimes it's easier just to refer to it in terms of absolute value. Finally, these are both percentages here. This is 40% over 13.33%. But the elasticity is just a number, not a percent. Okay, and so that is basically all there is to it. Again, there's a general formula, but then you have to calculate the numerator and denominator yourself. Okay, so a good is, we call a good elastic. So a good is elastic if the price elasticity of demand, the absolute value of the price elasticity of demand, is greater than 1. So in other words, if the price increases by 1%, quantity demanded falls by more than 1%. There's a big response, so therefore it's elastic. But a good is inelastic if the absolute value of the elasticity of demand is less than 1. So for example, for cigarettes or goods that may be addictive, if the price goes up, people still consume them, right? Maybe a little bit less, so there's not a big response. So we call that inelastic. And then finally, if the price elasticity of the absolute value, the price elasticity of demand is exactly equal to 1, we call that unit elastic. It turns out that I already mentioned at the beginning of this lecture that the slope and the elasticity are different concepts. And we can see that clearly here because here's a demand curve, right? It has a slope. The slope is the constant across the whole demand curve, right? It's if we go rise over run, we have 1 over 200. So that's the slope. The slope doesn't change. But the elasticity does. We just calculated the elasticity between points A and B. We found that it's negative 3. For practice, you should try calculating the elasticity between points C and D and between points E and F. You will see that it's negative 1 here and negative 0.33 here. So depending where we are on the demand curve, the elasticity changes. This is for straight line demand curves. And why is that? Well, here we have a high price, right? So if the price changes by 10 cents, it's not a big percentage change, right? So the denominator is small. But here we have a low price. And if it changes by 10 cents, that's a big change, right? So the denominator is large. And at the same time, here we have a low quantity. So a small change in quantity is a big percentage change. Here we have a big quantity. So a small change in quantity is a small percentage change. That's the reason behind why the elasticity differs depending where we are on the demand curve. It turns out that if you want to raise revenue, let's say you're the manager of a company and you want to raise revenue, if you're operating on the portion of the demand curve that's inelastic, like say you're down here, if we increase the price from 20 to 30, notice this is the inelastic portion of the demand curve, right? What's going to happen to revenue? You increase the price, and what happens to quantity demanded? It falls, but does it fall by a lot or a little? A little, because this is inelastic. So therefore, what do you think is going to happen to revenue? Increase. What is total revenue, by the way? It's price times quantity. So total revenue just equals price times quantity. Right? For a firm, this is the number of units it sells, and this is the price that it gets for selling each unit. So it turns out when we're in the inelastic portion of the demand curve and you raise price, total revenue increases. But if we're in the elastic portion You raise price, and there's a big fall in quantity demanded. So therefore your revenue falls. So there's this makes sense if you reason your way through it. You can also prove it to yourself mathematically. It turns out this relationship exists between price changes and total revenue changes. If the good at the current price, if the demand at the current price is elastic, then an increase in price reduces revenue because a lot of people switch to something else. And the same, at the same time, if you reduce the price, that will increase your total revenue. Why? Because you lower your price, you get a lot more customers. If it's elastic. If it's inelastic, it's the reverse. You increase the price, you increase total revenue. And if you reduce the price, you reduce total revenue. So it turns out we're going to be talking about how firms make pricing decisions in subsequent chapters. This is only considering demand and total revenue, right? Do firms want to maximize total revenue or something else? Something else. And what is that something else? Profit. They have to pay to produce these goods, right? They don't just fall out of the sky. They have to produce them. And so generally firms won't their objective is not to maximize total revenue always. Usually it's profit. But nonetheless, this relationship does exist between total revenue and elasticity. As I mentioned at the beginning of the lecture, the concept of elasticity also matters for many policy questions like minimum wage. There are some demand curves. These are two extreme demand curves. Here, if the price increases, quantity demanded stays the same. So this is called a perfectly inelastic demand curve. And it's hard to find examples of goods that are perfectly inelastic. Some are more elastic than others, but the example in the book is insulin. So if you're a diabetic and the price of insulin goes up, well, you're going to keep consuming the same amount because you need it to control your disease, right? And if the price goes down, you're not going to consume more because you already, there's an optimal amount. So maybe that's a good example. And then here we have perfectly elastic. So if the price goes up even 1 penny, consumers stop. They buy nothing more from it. And at the same time, if the price falls by 1 penny, consumers demand a lot more. And so why would that be? Well, imagine we're in a very competitive market like for wheat. There are many wheat farmers. They all charge the same price. If one wheat farmer tries to charge a penny above the market price, no one's going to buy it from him. Right? And vice versa. If he undercuts people by 1 penny, he'll sell everything he has. There are also these, we looked at these straight line demand curves. And we saw that with a straight line demand curve, the price elasticity changes depending where we are, right? These are some examples of curves where it doesn't change. For example, up here, from this point to this point, between there, the price elasticity of demand is -1. And between here and here, it's -1. Between here and here, it's -1. Given the specific shape of this, and also this, these are called constant elasticity of demand curves. But in this course, we're going to be mainly dealing with straight line demand curves. So I would say this is not, these curved demand curves, aren't the most important thing for you to worry about, other than just to know that they're there. Finally, what determines the price elasticity of demand? Well, if a good has a lot of substitutes, like Coke and Pepsi, then if they try to increase their price, people are going to stop consuming it. If it's very important in your budget, like it's a large fraction of your budget, then people will be sensitive to price, and it will be inelastic. Finally, what about time horizon? Time is important. So let's say the price of gasoline goes up. In the short run, are people going to reduce their expenditures on gasoline? Maybe a little bit. But they still have to get to work. They still have to get to school, right? So they keep consuming at basically the same rate. But in the long run, what might happen? People learn how to take a bus, right? Figure out how to read a bus schedule or carpool or whatever. So they have time to adjust. And therefore, consumers will be more responsive to increases in gasoline prices in the long run than the short run.